All right, this is chapter 7, lesson 7. Last lesson is in this chapter on transformations. They are talking in this one about the area and perimeter of similar figures, so how they are related. And there is a relationship there. Sometimes it can be a little confusing. So we are going to go about this a little bit different way than what the textbook has. So the textbook has you having the perimeter of the similar figures. They have you taking them times a scale factor, and then to find the area, that have you taking the scale factor squared. Some of you have a little problem with scale factor in that maybe which one goes on top. Is it 6/7, 7/6, whatever it happens to be. I think it's probably a little less confusing if you use proportions. So that's the way I'm going to teach it out of this book today. The answers are going to be the same. It just, my work is not necessarily going to match the work that's in the book. So make sure that you follow along with what I'm saying. I'm going to use these examples that are in the book. But again, make sure you're following along with what I'm saying. And if you have any questions, jot down a question in your notes and make sure to ask me about it whenever you are in class. So we're talking about two rectangles here on example 1. Two rectangles are similar. One has a length of 6 inches and a perimeter of 24. The other has a length of 7 inches. What is the perimeter of that rectangle? So what I'm going to do is I'm going to have my first rectangle and I'm going to have my second one. All right, so it has a side length of 6. So there's a couple different ways you can set up these proportions. You could say 6 is to 7 because we got 6 inches on side length and 7 inches. So we could say that 6, so let's cross that part out for now. We're going to say side length. We're going to say 6 is to 7 as 24. Now where would 24 go? Did it go with the 6 or did it go with the 7? It went with 6. So 6 is to 7 as 24 is to what? You don't know. So 7 times 24 divided by 6. So it goes in there twice, 48, goes into 48 8 times, so 28. 28 is our answer. All right, so using proportions, find corresponding parts. 6 is to 7 as 24 is to what? All right, pause it and try. They got it down here. Okay, using a proportion. It says that they're similar. So if the perimeter of this LMN is 64, sorry, that's supposed to be a 6, 64, and that's the perimeter. So if the perimeter is 64, you want to know what is the perimeter of the small one. So again, find corresponding parts. 24 is to 18 as 64 is to what? So we are going to take 64 times 18. 64 times 18. 1,152. 24 times x. So I'm going to divide both sides by 24. 48 is our perimeter of the smaller one, 48 meters. Again, my work is a little bit different than what the book's having you do, but again, I think that proportions are easier, in my opinion. Proportions are easier and less confusing as far as the scale factor goes. So feel free to use that. If anyone's wanting to use scale factor, you can bring me the book and we can talk about it. And we can go from there. But my suggestion is to stay with the proportions. And also on ISAT, the Park Assessment, all of that, proportions can be used to solve so many problems. So if you get good with proportions, you will not have a problem with any kind of standardized test that we talk about like that. All right, let's look at the next example. In the scale drawing, the perimeter of the garden is 64 inches. So in the model, perimeter is 64. The actual length is 18. You know that the scale is 24 inches. So what kind of things are similar? What are the corresponding parts? Well, you know that this is 24 inches, right? And that would correspond in real life, in the actual length, to 18 feet. So there is something, though, whenever you talk about things, the units must be the same. So you can't say that 24 inches is to 18 feet. So there has to be the same unit. So rather than take and write this in feet, I would just take and write that in inches. All right, so 18 feet in inches is going to be 18 times 12, because there's 12 inches in a foot, so that's 216 inches. So what I'm going to say is 216 inches, which is my actual amount, even if I want to put an actual over here. Actual 216 is to 24, and that's my scale. This is my actual amount. So actually 216 is to 24 as what? This 64. Is that an actual amount or is that a scale amount? It says it's 64 inches in the scale, so that is going to go on the bottom. We don't know what the actual perimeter is. That's what you're looking for. Okay, so the actual amount is to the scale amount. We're looking for corresponding parts. 216 is to 24 as what is to 64? So 64 times 216. That would be 13,824 equals 24x. Divide by 24. 576 what? 576 what? We're all talking about inches here. Now, if I wanted to ever do something, oh, how long is that? 576 inches. We don't ever talk like that. So you can convert that back to feet if you divide by 12. Convert that back to feet, and you get 48 feet. Okay, so with that being said, I want you to try the next one down here under got it. Okay. Pause it and try that one, please. Back with me. 2 quilting squares are shown. The scale factor is 3 to 2. Basically what that means is those are corresponding parts. So if they are saying corresponding parts are 3 to 2, that's the ratio, 3 to 2. Which one of these do you think would have the 3 and which one would have the 2? Right, the bigger one would have 3, so it's saying 3 is to 2. Now, this doesn't have a 3 on it, this doesn't have a 2 on it. How would I know that? Well, using common sense, if I'm going to find corresponding parts, would my bigger part go with the smaller one or the bigger one? Of course it's the bigger one. So you're saying 3 is to 2 as what? Now, they're talking about perimeter here. Well, they don't give you any information about the perimeter, so you have to find it. So you know that these are squares, which means all sides are the same length. So on this one, if one side is 4, they are all 4. All right, so the perimeter of the small one, 16 inches. So I'm saying 3 is to 2 as, now, would that 16 go on top or bottom? Would it go with the bigger square or the smaller square? It would go with the smaller one, which means it has to go on the bottom. So 3 is to 2 as what is to 16? So 3 times 16 is 48. 2 times x is 2x. X would be equal to 24. And we are talking about 24 what? 24 inches. Why inches? Because that's the only unit given in the entire problem. 24 inches. Okay. Moving on, my little mathematics prodigies. Moving on. Example 3. Okay. The Eddingtons have a 5-foot by 8-foot porch on the front of their house. They are building a similar porch on the back with double the dimensions. Find the area of the back porch. Now, here's a pitfall which I don't want you to fall into. A lot of people will say, okay, well, the area of the front one is 5 by 8, so the area of the front one is 40. The back one is double, so that means the back one has to be 80. That is not correct, because I want you to look at something. If we have a 5 by 8, yes, the area of that is in fact 40. But if I double the dimensions, and this would now be what? 10 by 16. What is 10 times 16? 160. So that is not double. It did not say double the area. It said double the dimensions. So you actually need to double each of those dimensions and then find the area of that, right? If it said they're building one with double the area, sure, you take 40 times 2, they'd have 80 square feet, you'd be done. But they said double the dimensions, so you do in fact have to double the dimensions, which did what to the area? Look at that. Did it just double this? No, it quadrupled that. It took it times 4. Why times 4? Because you did 4 things, did you not? All right, so you're doubling this, you doubled this, which in turn doubled this and this. So now it's like you're taking 5 by 8 really fits where? Right there. 5 by 8, 5 by 8, 5 by 8, 5 by 8. So really you quadrupled the porch when you doubled the dimensions. So a lot of people find that confusing. So if it were me, which is the reason why I didn't have you do the scale factor where you square something like that, all right, which is why I had you do it like the proportion way earlier. And this one I would actually have you work it out. I think it makes more sense to you that way. If you can see 5 by 8, okay, you're doubling it to a 10 by 16, and you've actually ended up with 4 of those in there, all right? 4 of those in there. So they've probably got an example for you to try. Let's see here. Oh, how did I know that? I must be psychic today. Okay, pause that and try that one, please. All right, this one's the same kind of thing. Malia is painting a mural on her bedroom wall. The image she is reproducing is a 4.8 inch by 7.2 inch image. If the dimensions of the mural are 10 times the dimensions of the image, find the area of the mural in square inches. So you cannot take 4.8 times 7.2 and take it times 10. That's not going to work. It's 10 times the dimensions. So 10 times the dimensions. So you have to take 4.8 times 10, which would be 48. And then it's 7.2 inches times 10, which is 72. All right, so get our calculator up here. 48 times 72, 3,456, make sure your label's right, square inches. You could also put this as your label, square inches. Either one of those would be correct. 3,456 square inches. Now, just for fun, let's just try it the other way. What if I did 4.8 times 7.2? And let's take that times 10. Yep, you're still off by 10. Right? Still off by 10. You got 345.6. 345.6. So, didn't quite work, did it? Nope. So you have to make sure if it's 10 times the dimensions, multiply each of the dimensions first. Multiply each of the dimensions first and then do it. Okay. With that being said, that is all of 7.7, which in turn, that's all of Chapter 7. So, good luck with that. If you have any questions, let me know. Good luck.